Okay. So, earlier we mentioned about the unknown words, right. So, it is always possible to find a new word in a given sentence. For example, when somebody is giving a lecture, you will find a new word when he is speaking, right. So, immediately you wouldn't know the meaning of that, but based on the context you will be able to make it up and then move forward. So, in the same fashion, right, if the corpus did not have that word, so we should not let the model fail because of the new word that's been given as an input to find either the uh, probability of the sentence or of predicting the next word. So, we need to create a model so that the unknown words are also taken into consideration. How do we do this? See, that is what we are going to be talking about in this particular slide. In a closed vocabulary system, there is going to be no new word, right. So, we are going to be only talking about the words that are present in the given corpus. Whereas, in an open system like what we are doing in Google search and so on, so many new kinds of keywords we keep adding, and we want Google to really help us in terms of finding out where those documents are present and list them in certain orders, so that we would go through that and then find some info or data out of that document. So, there are two purposes, right. So, one is about building the model, second one is about querying it. When you query also, you are going to be really querying with certain words, and you probably may not know what are all the vocabulary that are used in the given corpus. So, you might use your own words which probably are not present in the corpus. So, even there in the query we have to really handle the out of vocabulary words, which we term as OOV. Okay. So, in this case what we do is we want to pick up certain words with certain frequencies. For example, there could be so many words in a given corpus with just one occurrences. So, we can probably term them as out of vocabulary words and then label them as OOV rather than the actual word itself. So, when a new word that comes in as input to the model, we can label that word as OOV. Okay. When we do that, and when the model has been trained to really look at the OOV based on the frequencies of the words that we have picked and call them as or label them as OOV, now we are not going to have a zero probability for a given sentence, correct. So, in that way we can really address the out of vocabulary words in a given corpus. So, this really eliminates our zero probability. Okay. So, we treat each and every word in the out of vocabulary as a regular word. Okay. So, during the model building, since we have labeled certain words with a frequency as OOV, those frequencies also would be available as part of the model, right. So, we would have built the model with those out of vocabulary words, and the corresponding probability also is available for every out of vocabulary word. So, when a new word comes, we label it as OOV. Now, this OOV is again available as part of the corpus or the model, and then when you use the model which had treated the OOV in the fashion that I have mentioned earlier, we will not have any zero probability for any sentence containing OOV as input. Okay. Okay. So, this is something that I have spoke about earlier, while picking up the corpus, right. So, it is really a big concern when you go for a big corpus. So, one good example that I have given as the third bullet point is if you want to have a joint probability distribution of 10 words in a language that contains million words as vocabulary, then we need to estimate 10 power 60 minus 1 free parameters. That many, the model that I have shown, right. So, we have to estimate so many of them. So, when I tried this model on a corpus that is available in NLTK, especially the brown corpus, it took more than 1.5 hours to really build that model. And while really testing your code and application, you do not really go for a very high model in the beginning. You just start with a smaller corpus and then build the model and make sure that your testing is all right with smaller models. Then once you are sure that your code testing, the model building and the predictions are coming out all right, go for a bigger corpus. Okay. So, we need to be really concerned about the dimensionality when you start building the model. So, you can't eliminate this.